Suppose a teacher needs to choose 3 students from a class of 20 to represent the school at a competition. Does it matter who was chosen first? No. Does it matter who was chosen second? No. The only thing that matters is who is selected. Whenever order does not matter, we're dealing with combinations. Let's learn how to count them fast. A combination is a selection where order does not matter. It's all about who or what is chosen, not the sequence. When choosing R objects from N objects and order does not matter, here's the formula to use. N combination R or N choose R will be equal to N factorial over R factorial times N minus R factorial, where N is the number of objects available to choose from, and R is the number of objects being selected. If you're simply choosing a group and positions are not assigned, it's a combination. For example, a club has 12 members. A committee of 4 members must be selected. How many different committees are possible? Well, first you'll need to identify N equals 12 and R equals 4. You want to choose 4 members from 12. So if we set up our equation, 12 choose 4 will be equal to 12 factorial over 4 factorial times 8 factorial. So that simplifies to 12 times 11 times 10 times 9 over 4 times 3 times 2 times 1. So if you multiply the numerator, that will be 11,880, and multiplying the denominator, that will be 24. And if you divide, that will be 495 possible committees. In example 2, a lottery requires selecting 6 numbers from 49 numbers. How many possible selections are there? So 49 combine 6, or 49 choose 6, will be equal to 49 factorial divided by 6 factorial times 43 factorial. And that will be equal to 13,983,816 possible lottery selections. Why a combination? Because, for instance, 1, 5, 12, 20, 35, 49 is the same selection as 49, 35, 20, 12, 5, and 1. Order doesn't matter, only which numbers are chosen. Now let's say that you feel like eating pizza today, and the pizza shop offers 8 toppings. You choose exactly 3 toppings. How many different pizzas are possible? Here N equals 8 and R equals 3. So 8 combination 3 will be equal to 8 factorial divided by 3 factorial times 5 factorial. And that will be equal to 8 times 7 times 6 divided by 3 times 2 times 1, which will be 336 over 6, which is 56 possible topping combinations. Here's your challenge for today. A basketball coach has 10 players. He must choose 5 players to start the game. How many different starting lineups are possible if positions are not assigned? Pause and try it before reading the solution. So in this case, we have 10 players, N equals 10. We want to choose 5 starters, so R equals 5. Using combination, 10 choose 5, that will be equal to 10 factorial over 5 factorial times 5 factorial, and that will be 252 possible starting lineups. Students often confuse permutations and combinations. Ask yourself one key question. Does order matter? If the answer is yes, you'll use permutation. And if the answer to that question is no, you'll use combination. Now that you've mastered the 4 core counting tools, you're ready for the most important skill. How do I know whether to use a permutation or a combination? Thanks for watching. Please like, subscribe, and share with a friend who loves math. And don't forget, Math success starts when you stay on the fast track.